Now it is time for us to practice, and practice we shall. By the end of this video, you should know how to find the equation of a line if I give you a point and a slope. Any point, any slope, and you'll be able to do it. We'll also talk about how to, kind of a repeat of what parallel and perpendicular means, and how that can be used with this formula in a very similar manner as we did a couple videos ago. So let's talk about that. Now there was two things that I know that you have to write the equation of a line. It's a point and the slope. If you have those two things, you win. You win at life. That's yay. And you can do it. It's not even hard. You guys can totally are at that level right now. So you need a point and a slope. If you've got it, then you can fill out the point slope formula. It tells you what it needs. You need a point, x1, y1. You need the slope, m. You need to know how to distribute and how to move one constant term from the right side to the left. That's basically it. Let's practice a couple times, and then we'll talk about parallel perpendicular. It'll be more of a quick video for us. So let's find the equation of a line that passes through that point and has a slope of this. This is the easiest case of finding the equation of a line. I give you the point, I give you the slope, and you run with it. The other ways that we can do this, so looking forward to the end of this video and the next video, if you always need a point and the slope, here's what I have to give you and what you have to find. Here's the options. Listen carefully. I always have to give you at least 1 point. That must be given. I also have to have the slope. Now I can give that to you in one of three ways. I can literally give you the slope, like I've done here. That's easiest way. I can give you 2 points, in which case you find the slope first and then use one of those points in the slope you found. Or I can give you an equation and tell you parallel or perpendicular. So I have to give you a point no matter what. But the other three options are I give you the slope, that's easiest. I give you 2 points, you find the slope, you know how to do it, you can totally do it. Or I give you the equation of another line and I tell you to find the slope from that using the words parallel or perpendicular. And we've done that too. So this is putting everything together. It's a great lesson for that. Here, I've given you a point and I've given you the slope. I still want you writing stuff out. I still want you writing out what the point is explicitly. I want you writing out what the m is, what the slope is explicitly. Just by doing that, you get the numbers in your head. You're less likely to make mistakes if you've written them down. It's giving you practice to kind of internalize what the numbers are that you're dealing with. You're going to make less mistakes. Now, as soon as you have a point and as soon as you have a slope, plug that in a point slope. I've mentioned in the last video, but I always do this. I always recreate the point slope formula with some blank spaces for x and y. Remember, x's go next to x's, y's go next to y's, slope always goes in the front. The reason why I do that is because when you're dealing with negative numbers, those parentheses just house them for you. It maintains operation, but it also maintains the negativity. I don't want you forgetting parentheses and accidentally counting this minus as a negative. That's a bad thing. It's going to lead you to different signs all the time. So for us, we go, okay, hey, that's point slope. I know that here's my point. X's always come first, Y's always come second. So I know what my X1 is, I know what my Y1 is, and I know what my slope is. All we've got to do is put them in the right spot. We've fixed 1 point. Let's put our X coordinates next to our X variable, our Y coordinates next to our Y variable. Make sure that we have our slope correct with its sign, and basically done. Yeah, there's some work to do as far as distribution, dealing with the fraction, but this is the filled out point slope formula. If you're given a point, you can plug in for your point. If you're given your slope, you can plug in for your slope. And if you can solve for y, you get slope intercept, and that's something that's very easy to graph. On the left-hand side, that parentheses really wasn't doing anything, so we can drop it. On the right-hand side, we're going to be careful to maintain my negative 1/2. I'm going to take just a moment. We're going to simplify this. So x minus negative 2, subtracting a debt, removing a negative. Okay, that's adding. Subtracting a negative is adding. So that's x plus 2. Now, whether you've got to take your calculator out or whether you're good at fractions in your head, that's fine. But let's make sure we get this right. When we distribute, we're distributing negative 1/2. So on the right-hand side, negative 1/2 times 1x, I literally do say these in my head. Probably sound like a crazy person, but I want to make sure my signs are correct. Negative 1/2 times positive 1 is negative times positive is negative. Negative 1/2 x. Negative 1/2 times positive 2. I know a negative times a positive is a negative. I'm going to write a minus. 1/2 times 2 is 1, so I'm going to get a minus 1. We are almost done. Do you get it though? Do you get where the points come from? If you know your point and you know your slope, you can fill out your formula very quickly. Just plug in your points, y's next to y's, x's next to x's, slope goes in front. Simplify the inside of parentheses, distribute very carefully, and then solve for y. It's just going to take one step. If you want to be absolutely sure that you got this right, double check. Make sure that the slope you have here, hey, it's solve for y, it's easy to find. Funny how that works. The slope you have here matches that number. If it does, that's great. If not, fix your joke because you made a mistake. Also, you need to be able to plug in this point and it work, and it be a point on that line. So we're going to plug in 3 for y, plug in negative 2 for x. Negative 1/2 times negative 2 is positive 1. Positive 1 plus 2 is 3. I know that point's on the line, and now I'm guaranteed that I have a right answer there. By the way, could you graph that? Could you find the y-intercept of 0, 2? From there, go down 1, right 2. Is it becoming easier for you? Because that's awesome if it is. That's fantastic. Tell you what, I would love it if you would pause the video and do that on your own. Given that you hopefully have tried that or not, we'll start with it. But there's really only two things we need. We need a point, we've got one. We need a slope, we've got that too. I'm still going to encourage you to write out your point. What that does for you, and it only takes a couple seconds, but what that does is that puts in the numbers in your head. By writing them out again, you're seeing them one more time. I know that if I see x1, I'm going to put negative 10. And if I see y1, I'm going to put positive 1. I'm also going to write out my slope. That's 2/5. Hey, there's only two things you need, point and a slope. We've got both of them. That means we can fill out point, slope. So let's create some parentheses. We always start this off as y minus and x minus. And the reason why, some people get so wrapped up, and you guys are smart people, but you get so wrapped up in doing the math in your head that we do really weird errors like, oh, well, I'm subtracting a negative, so it's going to be plus, but then you put plus with the negative still. That happens often. So it's best in formulas when you're evaluating, the best practice is don't do any math in your head. Write the formula out exactly as it says. Use parentheses where you're plugging in numbers. Just put the numbers in there. So y minus 1. I know y is good next to y's. X minus negative 10. I know x is good next to x's. I haven't made mistakes on my signs. I have minuses between both numbers. It looks pretty good. I'm going to put my slope last. And then we start quickly, but accurately simplifying. Y minus 1, no problem. Let's leave it hang there for a second. 2/5 looks good. X, okay, x minus a negative. I'm subtracting negative, that means I'm adding. That's plus 10. Your next step, there's nowhere to add 1 right now. That's your last step, so don't worry about that. I want to simplify both sides before. This should ring a bell. We've done this all the way back in, like, I don't know, 20 videos ago. Simplify both sides before you start working, adding, subtracting to both sides. So 2/5. So I'm saying in my head, 2/5 times 1x, positive, it's a positive. So I'm going to get positive 2/5 x. Y minus 1 isn't going to change yet. 2/5, positive 2/5 times positive 10. Positive times a positive is a positive. I say positive, I write plus. Now, 2/5 times 10. Pull out your calculator if you're not good at fractions. That's okay. I need you to get the fractions right. So 2/5 times 10, or think 2 times 10 is 20, then divide it by 5, or think I can simplify 5 with 10. I can get 2 times 2 is 4. Either way you go. 2 times 10 is 20, divided by 5 is 4. or you simplify 5 with 10, you get 2 times 2, that's 4. No matter what you do, you need to be getting plus 4. You are almost done. Almost. Just solve for y. Put this in slope-intercept form. That's the equation of line. Let's check it. Let's make sure our slopes are the same. Slope matches. That's a pretty good sign. Secondly, plug in your point. Negative 10 for x and 1 for y. So if I plug in negative 10, this better give me 1 when I'm done with it. So negative 10, let's see, it's negative 20 divided by 5, it's negative 4 plus 5, that's positive 1. Positive 1, I know I'm right. That's the way we check our work. Now, we're going to move on a little bit, but this has to make sense before we go any further. Are you seeing that if you have one point and you have the slope, that we can plug it into point slope, and it's pretty easy. Use parentheses, make sure you're simplifying effectively, efficiently, quickly, but accurately. That's the idea. Now, what if I throw those words parallel and perpendicular in there? We're going to see how that works once I erase the board. Just for fun. Let's go back to it. I've been preaching at you for a long time about the two things that you actually need to make the equation line. A point and a slope. We just nailed the first version, the easiest one, granted, but the first version, where I can give you a point and I can also just explicitly give you the slope. In that case, it's plug and play. Plug in the numbers and you just have some fun because you're solving for y. That's it. The second option is I have to give you a point. Notice that in this. I give you a point for sure. I have to. And then you have to find the slope. So no matter what, you need a point and a slope. I can give you both, or I can give you a point, and you got to find the slope for yourself. The first option is I give you an equation, and I tell you how to relate it to what you want. In other words, I give you an equation like this one. I say, I want you to find me a slope that is perpendicular. Or I give you an equation like this one, and I want you to find me a slope that is parallel. But those words now make sense to us. Do you remember how parallel slopes relate? Are they equal? No, they're not equal. They're opposite reciprocals. Do you remember that? If not, it might behoove you to go watch a couple videos ago when we talked about parallel and perpendicular slopes. Parallel, same slopes. So right now I've given you points, and I've given you a way to find the slope that you need. This is another reason why we write out point and slope every single time. So I'm giving you points no matter what. So our point here is -3, -2. The slope, by the way, if that's not solved for y, your first order of business is to solve this for y. I'm not doing it here because we've already done that idea, but you would be able to solve any equation for y. And then right here, right there, you know how to find slope. You guys are getting good at it, I'm sure, if you've been practicing. So your slope is 1/2. Let's find the perpendicular. That's why we write it out twice. We don't let our brains confuse us and put 1/2. You're going to get it wrong. I need you to find me a point and a slope. I can give you the slope, or you can look here and say, hey, I need something perpendicular to this. I need something negative reciprocal to this. What I need is to flip this over and make it negative. Not positive 1/2, but negative 2 over 1, negative 2. Now, I have given you a point. You've been able to find the slope based on a relationship to a different slope. That's what I've given you, a different line. As soon as you have that, this stuff is now meaningless. I don't care about that number. It does nothing for you. You don't even have to look at it. I don't care. All I care about is the point that your line has to go through, given, and the slope that you need. The slope that you need was given in this case by telling you a relationship to a different slope. My encouragement is to do this right now. See if you can work through this. What I'm going to do is talk about the next one, and then we'll go back through both examples. Right? It's not about crunching numbers at this point. It's your understanding about how to get the slope. So try that if you want to. I'm going to come back to it in a moment. Right here, let's look at the different way we can see this. So again, you need two things, point and slope. Your point is always given. Oh man, fractions, what the heck? I've given you the point, I have to. Now your slope. So that besides just giving you the slope, I can give you a relationship to a different slope. Again, this thing's got to be solved for y. So if it's not, you spend some time, you solve for y, you make sure you're right, and then you have it in order, and you look right here. You're going to be given a word that relates the slope you want with the slope you're given. That word in this case is parallel. Here it was perpendicular. If you have perpendicular, reciprocate, change the sign. If you have the word parallel, parallel means same slope. We've talked about it. So I've given you the point. I've given you a slope. You relate what I've given you back to what you want. I want something that's parallel to that. I want something that has the same rate as that. I want something that has the same slope as that. They can't ever touch, which means their slope is exactly the same. Perpendicular, negative reciprocal, or opposite reciprocal. Parallel, same slope. I hope that you're seeing it. I always give you a point, but you can find the slope. Number one way, I just give it straight up to you. Number two way is I give you another equation. You solve it for y. You look at the word that I'm using to relate them. Perpendicular, use the opposite reciprocal slope. Parallel, use the same slope. Other than that, now you just forget everything. Notice how that, I'm just giving you a random number, but that has nothing to do with this problem. I don't care where that crosses the y-axis. I care that it goes, this equation goes to that point and has that slope. That's it. Once you have these two pieces of information, forget the rest. Just try the slope, or the point slope form of a line, and then work it down to solve for y, for slope intercept. If you haven't done that, I need you to try that right now. So take your slope and your point, plug it into point slope. I always like to write x1, y1, just so I know, just so I don't get confused. It doesn't take any extra time to do that. Then what we do is we're going to create some blank spots for our numbers. If you create that pattern in your head, you're less likely to make mistakes. Do it the same way every time. That way you have this pattern down. When you see, hey, I'm trying to solve for the equation of a line, I'm trying to find the equation of a line, I know I'm using this. I know I'm using that formula. I got to find a point and slope. Give it to me, cool. Find it for something else, not a problem now. And then we start plugging in some numbers. So I know that my y variables, y point, y coordinate goes with my y variable, x coordinate goes with my x variable. I'm checking my signs all the time. -2, -2, -3, -3. I'm not doing math in my head. There's no way I'm putting a plus here. I know myself. It's too easy for me to make mistakes like that. So I'm showing all my parentheses. It houses the negativity. It maintains the order of operations. It maintains the operation. I put my slope right in front and we go through it. Y minus -2. Oh, that's y plus 2. -2 stays. I'm not distributing yet. I'm just simplifying. Simplify both sides first. X minus -3, that's x plus 3. I'm going to be real careful here because I've been dealing with signs. So I'm double checking my work. I'm going to distribute. That continues to simplify. On the right hand side, let's see, -2 times x, -2x. -2 times +3, negative to positive, negative. I say negative, I write minus. And then last step, I want you solving for y because that's a very easy form of a line to graph. y equals negative 2x minus 8. Let's see if it works. Is this slope perpendicular? You should be checking because it'll show up if you're wrong. Is this slope perpendicular to that slope? Yeah, flip it over, change the sign, I got it. Is this point on that line? That's something you should check. So negative 2 should go right there. So whatever I plug in for x, it better be giving me negative 2. Let's try it. Negative 3, so negative 2 times negative 3, that's a positive. Positive 6 minus 8, that's negative 2. Hey, I know I'm right. There's no question I'm right. That's off. There's never a question I'm right. I'm just joking. But now that you can be sure about that, that's a confidence builder. You go on a test and you're like, hey, I know I'm right now. I don't have to guess at it. I know that that's a correct answer. That's great. That relieves your anxiety, relieves your stress on the test. You know that you're right if you checked your answer. That's fantastic. You move on. The next one. This one looks kind of nasty. There's fractions everywhere, but man, fractions happen. There's a bumper sticker for that one, all right? It says, happens. That's fractions. Well, let's just make sure we're at least plugging the numbers in correct. So y's go next to y's. X's go next to x's. I've already created space for that. I already have my point, my slope. Slope goes right in front. Let's go slowly through this. Subtracting a negative, I know I'm adding. On the right-hand side, that negative 1/6 stays. X minus 2, okay, that wasn't really doing much, but it didn't hurt us. Now, we might want to pull out our calculator just to make sure that we're right, okay? Just to make sure that we're distributing correctly. We simplify first. We let that 2/3 hang on for just a minute. Negative 1/6 times positive 1x. Negative 1/6 x. Negative 1/6 times negative 2. Negative times negatives are positive. I'm going to write plus. I'm also thinking, well, hey, 1/6 times 2, I already know it's plus. That's going to be 2/6. That's 1/3. We're almost done. We just have to subtract 2/3 from both sides. 1/3 minus 2/3, you're going to owe 1/3. It's minus 1/3. And then we double check it. We make sure that we're right. I know fractions are intimidating. Now we got fractions and equations. That's a lot of stuff. You can do it. Use your fraction buttons on your calculator if you have to. But check it out. Is this parallel to this? Hey, same slope. That's a good sign. That's probably enough to check it as far as your slopes, but it's not enough to check it as far as your y-intercept. You need to make sure that this point is on that line. So what that means is I need to be able to plug in 2 and get out negative 2/3. So this answer's got to be negative 2/3. Let's try the 2. Negative 1/6 times 2. Negative 1/6 times 2 is negative 2/6. Calculator will do it for you. Simplify, that's negative 1/3. Negative 1/3 minus another third is negative 2/3. Hey, that's exactly what we have. Now we're sure we're right. So we've just covered the first two cases, basically, of what you need to make the equation of a line. You need a point and you need a slope. I will always give you a point. You'll have to be given a point. And then you can be given a slope, or you can find it from another equation, given a reference word like perpendicular, opposite reciprocals, or parallel. Keep the same slope. That's how you use it. Next video, we're going to talk about how you find the equation of a line between 2 points. That's the last one. You still will need a point and a slope. We'll have to find the slope. So I'll see you for the next video.